Cool. Well, hello again, and welcome to another edition of the Lunch and Learn. I am your host, Joe Vincent. I don't have anybody else helping me today, so it's all on me. Success or failure, crash and burn. I get to take all the credit or all the blame. However, that's only true if you're only watching this camera, because in this camera it looks like it's just me, but it's not. And we have a really cool added feature for this episode that will help you see all of the people that are behind the scenes and beside the scenes and just waiting in the wings for me to stop talking so that they get an opportunity to talk. You can see all of those people right now if you go to the link here at the bottom third of our screen. That is a link to a live three-dimensional camera, and it's hosted right now on YouTube. I actually have it up on my screen. I was showing off my socks earlier, and then I realized that I just did that for anyone who was watching the YouTube channel. There it is. And so on that view, you can see that this room is a mess, first of all. And second of all, there's a lot of people behind the scenes. We got Corey over there, we got Gene, we got Barb. Dean's gonna sit here patiently throughout this opening segment until we get to the meat of our episode today. But we're gonna leave that camera up and running the whole time. Pro tip for those of you who like things like that, during the commercial breaks and the video breaks, I don't think you can hear us, but you can see us. So when I make a quick dash to the bathroom during Jamie's 3-minute video today, you'll know all of our secrets. We had the Aquanet and the mirrors out earlier fixing our hair, just so that we could look as good as we do. This doesn't happen all by itself, obviously. Today is, before I get into it, Corey's prompting me via these images down here on the bottom. You can also watch the feed of this broadcast live on Facebook, on the Facebook. And we promise none of the data that we collect is sold to any third-party sources or research firms. Just go to its.atsu.edu/FB and you can catch the feed there. You can also see the finished, polished up, packaged program of this episode. It goes up in the next day or two after we finish up an episode, and that's on YouTube at the link there below. So if you want to comment or send us questions, use that live feed from Facebook. And we'll be able to catch those and maybe even work them into the episode and get you answers right there. If you want to refer other people to this episode after it's over, use the YouTube link because Corey does some pretty good magic to make it look like we knew what we were doing and we prepared way in advance for all of this. So the studio is a mess today, even by our standards, because we have some really cool stuff to look at and talk about. And we got Dean Maag with us. Dean is associate vice president, assistant vice president?
Nope, just a manager.
Great big grand poobah master of information technology, sir, academic multimedia. And Dean is the tech guru over here, and he's brought a bunch of stuff with him today. All of it?
All of it.
All of it's here. We got a custom computer. We got a 3D virtual reality headset. We have some augmented reality stuff. We got some 3D printing stuff, and that's what we're going to talk about today. Virtual reality, augmented reality, and 3D printing technology. And so Dean's going to walk through some of that with us today, and then show us how there are applications that are being used now or that are coming into the field now to impact the way we do healthcare and healthcare education. And that's where we close the loop and make it relevant to an ATSU Lunch and Learn. Because outside of that, there are just some really cool toys
for sure.
And neat stuff on the horizon. So Dean, thanks for being here with us today. And I'm going to let you run the deal the way you've got it segmented, but
sure.
Tell us about all the stuff you brought and what's going on.
All right, well, what we were going to do is kind of give you a basic intro to all the different technologies that we have around here, a lot of our cool toys that we have here at ATSU. We're working them into medical education, and they're also working them into medical practice as well as things go on, as the technologies develop. I want to go ahead and load my slides there, Corey?
Yeah.
All right, so I put together, it's not an not a huge death by PowerPoint type of PowerPoint. It's just some
That's
images
good,
and stuff, and so some of the stuff we're talking about today is pretty high on the geekometer. So
see that.
We're going to kind of go back a little bit and talk about some of the basic terms of things. What I was going to cover first. So you hear these acronyms kind of thrown around. You have 3D and VR, AR. So 3D is a three-dimensional object. Virtual reality is just that. It's virtual. You're not actually seeing the real world. And augmented reality augments the existing world. And 360 is a little bit different. It's kind of like what we're doing with this the Gear 360 camera here, where you're just seeing a video playthrough that's captured with fisheye lenses. The 3D objects, kind of going back to talk a little bit about that, they're objects that are defined in a computer in 3 dimensions. They have length, width, and height to them. And if you're mathematical, you can think of X, Y, and Z axes from back in high school.
You weren't kidding about the geekometer.
Yeah. So, and 3D objects like this are then used in the other technologies. Augmented reality and then virtual reality use the 3D objects inside of them. And then also, in Star Wars movies or the Avengers movies coming up where everything's CGI, that's all based on 3D objects that are moved in an environment. The other thing with the 3D objects is they can be printed into the real world. Both on the Missouri campus and the Mesa campus, we have 3D printers, several of them on the Missouri campus, and then we can go ahead and make objects. I brought a few things here that are kind of small, but like a vertebrae. You hold it there. And a set of teeth that we've scanned and made. And you'll see a little bit of how this was done in Jamie's video a little bit later. The DO TouchNet Award, A.T. Still's hand. That's for you, Joe, for hosting today.
Wow, yeah, thank you. Top performer.
Yeah. So there are objects that are digital that instead of remaining digital and then being viewed through virtual reality or in a movie, we brought them into the physical world by printing them through a specialized printer that uses plastic. And some of the other 3D objects with the 3D printing, you can print things that are impossible to make in the real world. So you can have impossible type objects. They're actually using 3D printing to do some aircraft engine parts now, so they can print with metal. They lay down a metal powder and use a laser to melt the metal to 3D print.
Oh, cool.
Prosthetics. One of the kind of cool things they're doing now with, especially like people in the military or in bombings and things like that, where they might have a facial injury, they can 3D scan or MRI one side of their head and recreate it on the other side of their head to print implants to match their face, to reconstruct a face. And then one kind of cool thing, it's not quite 3D, people don't think about it that way, but like ultrasounds now with the 3D and the 4D technologies and ultrasounds where you can get a 3D visualization of a infant in the womb. So kind of moving on from 3D objects into something that uses 3D objects, I'm going to talk a little bit about virtual reality. So virtual reality creates a virtual world for you to be in. You're cut off from the rest of everything else. You usually have headphones on where your audio is at, and a lot of times the audio is directional, to where if something is happening over here in the world, you can look over at that because the audio tells you it's there. There's a picture on the screen here of the headset that's an HTC Vive, and the fronts of the headsets are blocked off to where you can't see the outside world, so you're kind of sealed in. There's smartphone-based type things. I've got a Samsung Gear VR here, and it's kind of the same way, where it's just you snap your smartphone into that, and then it displays things. It's not as robust as some of the appliance-based ones, which we'll try here in just a minute with you, Joe.
Oh, good.
And then, for something cheap and easy for the kids, you can get something called a Google Cardboard, and they're $7-10, and you can buy them at Walmart or online at Amazon.com, and you end up just put your smartphone inside of this. It's got 2 little lenses, and you put your smartphone in there, and there's special apps you can use too, and then it tracks your head movements where you can look around within a virtual world. This isn't nearly as immersive as some of the other stuff. The Gear VR and the Samsung, the HTC Vive and the Oculus Rift that are more pro model ones, and the stuff's evolving minute by minute, it seems like.
Yeah, sure. As soon as you get it, there's a new version. It's like a flat screen TV.
And kind of some of the downsides to virtual reality are that you are enclosed, so if there's movement on the screen and you're not moving, it can cause some people like vertigo or motion sickness.
Oh, yeah.
So some people, it affects some people more than others, just like any kind of motion sickness does. And the better the system, the less that tends to occur. The higher the frame rate, it tends to be better. And some of the medical uses for VR at this time, the military is like the big user of it. For PTSD and some other things like that, they can put people in a virtual world and it helps them cope with some of the stuff they've seen.
Oh, really?
In the hospitals, they're using it in like burn wards, and they show people like images of the Arctic and penguins, and they're nice and cool, and it shows, it's scientifically been shown to reduce like pain levels on them.
Really?
Yeah. So I mean, there's some of the stuff for VR. A lot of it is gaming, but there are some medical uses for the virtual reality, and a lot of it seems to be around kind of therapy and mental well-being.
Yeah.
And people think of VR being new. I went and scanned this today. It's a boarding pass I had for like in 1992 in St. Louis Union Station. They had a giant thing you stood in and had a headset on. So I mean, it's been around a long time, but now that we're moving into more smartphones and faster processing, the graphics are better, and it's more mobile that way. But so virtual reality and 3D stuff has been around forever. Mm-hmm. People don't think of it that way, but it's just now really gaining traction and gaining acceptance.
Interesting. Yeah, when I think about that stuff, I remember the first Pixar movie, Toy Story, sort of the first ones to start using more 3D type modeling for cartoons, right? And Toy Story was like a huge leap forward in animation. Yep. And a lot of that stuff starts as, it's interesting how some of it starts in like military application and then works its way down, and some of it starts in like gaming and entertainment application and works its way up, and they end up becoming cross-platform. Right. Which kind of carries us to why is it at ATSU? Like, first of all, I think I speak for everyone when I say no fair. Why do you get to play with all the toys? And second of all, and I don't want to jump ahead in your presentation, but I think maybe that's where everybody goes in their brain is, what do we do with it?
Right, and with us, it'd be more medical education type things. It's very immersive to where you can bring up an object and look at it close up, and I guess that's kind of a good segue into heading over to the virtual reality machine here for you and put your goggles on. Oh,
you want to do it now?
Let's do it now.
Okay. Okay, before we do that, I have a couple questions. Can I clarify a couple of things?
Certainly, yep.
So I get 3D printing. I think we've had that around here enough that I think everybody gets, this is a plastic printed hand, and we've all watched one of those things work, and we get it. You mentioned some medical applications. I think that there's some stuff, especially in dentistry, that they're able to do. Right. And so that's where it sort of brings it from, hey, here's a cool thing we can print, to here's a cool thing that's on site where your dentist doesn't have to send off for 6 or 8 weeks.
It's really big in dentistry as well, too, where now dentists are able to print in their shop.
Right, and instead of waiting 2 months, your little personalized appliance can be ready in a couple hours. That's really cool. Virtual reality and augmented reality were ones that took me a while to understand the difference. Because I think I was aware of Google Glass that came out several years ago. Yep. And that was the first big consumer application, augmented reality, where, correct me if I'm wrong, I'm actually seeing the real world. Right. And then the augmented reality adds overlays.
Right, you're augmenting the real world.
Right. So that I feel like Terminator, right? I look at a person and I automatically can see their vitals and their weak spots and their where I should shoot them, and that kind of thing. Their heat
heads-up display type of a thing.
That's right, like a HUD. And then virtual reality, for everybody who's seen Ready Player One, is like Ready Player One, where
Right.
There's nothing about the real world.
Right, or even Tron from back in the 80s.
Yeah, or Tron, right. Well, you went super old on us there, Dean. You got to be careful. I'm not old enough to remember Tron. But yeah, so that it's completely immersive.
Right.
And I could walk into a wall. Like my physical presence is almost
Right.
forgotten.
Right.
And there's applications for all of those. Okay, so what are we going to do first?
First, we're going to do the virtual reality, then we'll get to augmented reality after
All
that.
right, virtual reality. Okay, so I'm gonna take this guy off. So Gene and Barb, especially if they're watching the 3D camera, that I can actually talk to them. This is cool. Any pranks that you wanted to pull, any gestures or things that you wanted to do to me, and I didn't know it. I think now will be the time. Just to,
a surprise for you.
okay, all right, great. I'll find out about it later when I watch
Put
the
your headset on there.
finished video on YouTube, right? Okay, here we are. Oh, and they can see.
Yeah,
So the feed we have right now is what's going on in the headset.
exactly.
Ah, cool. All right.
Just putting on the headset here, and with 3D, in a lot of the virtual reality, you use controllers to help yourself, because you're in the virtual world, so they can't see your hands. So you want to pick up that?
Oh, that's so weird. I can see that. Can they see that, Corey?
Yeah.
Yep.
Look, it's like I have two lightsabers.
Exactly. So then you can point them at the model, and pick out different features on that on the guy there.
Oh, I see.
Yeah, you can-
Now wait, I want to test it. I can walk around this guy.
Correct.
Yeah? I feel like I'm kicking a cord that glitches it out a little bit. So here he is. Here's his front.
Yep.
I feel like I should be able to reach out and touch him. That's so weird. And then I can go around
Correct.
and go all the way around. This is awesome. So as an anatomy, I could hug him. As an anatomy student, it feels like this should be helpful, yeah?
Right, and then you can pick different systems of the body. You can pick skeleton and
Okay, so let's do skeleton, and I just trigger it.
yep, and point your finger at one of the skeleton.
So let's just do a skeleton.
Yep.
Oh, there he is. Nice
Then-
teeth.
You can click on the individual pieces in the bones. It will give you an explanation of what they are.
And they can still see what I'm seeing, Corey?
Oh yeah.
So like, I feel like I can stick my head inside here.
Yeah.
That's incredible. Look, there's his chest bone. Now I'm inside of it. I wonder if I can, what happens if I,
Yep.
oh, that is ridiculous. Hang on,
New meaning to getting it.
you ready?
You can look through his eyes.
Where's his eye holes? There they are. Well, they're not very big. Huh. Who knew so much?
It'd be for the nerves. That's
Who knew so
for
much stuff was in the
optic
way?
nerves. There you go. Now
I'm
you're
getting there.
through the sinuses.
Yeah, there we go. That is so. Ooh, look at all that stuff. What is all that?
That'd be your sinuses.
We need a doctor in here. Yeah. Do you see all those little?
Yeah.
Oh, that's cool. Okay, I'm sorry. We'll spin this.
So there's a lot of different applications we have for that, and
Yeah, and this now I've got a. What have I got? An arm?
arm, yeah, with the shoulder blade on it.
Or I could do a knee. Oh, that's cool. It's even got part of the spine connected in there. Yeah, all right. Sorry, don't let me get distracted. Skull base, hang on. We should do a brain, yeah? A big brain.
Sure.
Boom. Now look. And all of his nervous system. Oh, I so want to reach out with my hand.
Right.
And I expect you to be right there.
Right, and
but
some
you're
of
not.
the newer systems and the more advanced systems we're doing now do have haptic feedback, to where you could either
Where,
wear a
like, I
glove or
could-
something like that, and you would touch something and you feel it.
Ah, got it. I just can't get over, like, look at that in there. I can't get over how detailed this is.
And it's a lot different wearing that rather than seeing it just on the screen in the 2 dimensions. The 3-dimensional view of it is really immersive.
Yeah. So this has to be, do we use this a lot in education
Have
now?
rolled it out. Right now, some of this, the anatomy professors don't think is quite detailed enough, but we're getting there. But it would be it could be a good study aid for a student.
Look at, I cannot imagine the amount of work went in. Can you see that?
Yeah.
How I can like go into the middle
The heart you could, yeah, it doesn't.
or go through?
Yep.
Look
See
at
the
that.
valves.
That's incredible.
All right, we're going to
Look at
be
his
here all
tongue.
day if we leave you in there, so we better.
All right, are you going to take me out?
We're going to take you.
All right,
Just
okay.
go ahead and pull your headset off.
I wasn't really sure
right.
where I was. I appreciate you doing that.
Yep.
That was the coolest thing I've ever.
Yeah.
That was the coolest. Did you guys? I feel like it has to be a little different watching it than actually being in it. Like I could hear Dean's voice. I really wanted to turn around and see Dean there, and he wasn't there. The thing was completely immersive.
Yeah, totally. Get you in.
And I really wanted to grab the guy. I felt like I should be able to pick him up and move him. That was so cool. Thank you. We're still on the. There we are. All right.
Okay.
How's my hair? I'm just kidding. I'm not kidding, really, but I have to say it. Okay, so that was virtual reality. I assume there's some augmented reality stuff we could play with, but
Right.
let's give everybody a break. And we're going to go to look at Jamie's deal that he put together about 3D printing.
Correct.
And would you set that up for us? What are we getting ready to see?
It's Jamie kind of going over some of the projects we've done just to give people ideas what we can do. Some of the virtual, the 3D stuff, we can design things in-house or change existing models or scan things and then create something new. We've done it a lot for the research, Steel Research Institute. We're doing some dental work with the dentistry professors, and we're building little models of like the AT Steel's hand there. So there's a lot of interesting things we can do. So Jamie does most of this work for ATSU, so we're going to go ahead and have him talk a little bit about his projects.
Great, here we go.
Hey guys, this is Jamie Carroll from ATSU Academic Technologies, and I'm just going to take a moment to go over a few 3D projects that I've worked on, and I'll get right to it. The first scan project I wanted to cover is something we did for research support and ultimately the museum. The museum had a cast of AT Steel's hand, and I was able to scan that with our Ultra HD scanner, and then I cleaned it up in 3D software and then did a test print. And then once the client approved that and everyone liked it, we sent that file to the library for mass production. One of the more interesting and involved projects I worked on with research support and Steel Research Institute was this lumbar project, L1 through L5, where they had a model created and fabricated using brass, I believe, vertebra, and a wooden base with fine-tuned adjustment pegs, essentially. And they wanted to see if we can recreate pieces of this in 3D. Essentially, we could join the vertebra, a support system, and the base all in one piece in 3D software through scanning and then 3D editing, us to mass produce something and be precise and make multiple copies of it. All right, I want to cover this vertebral side bending project that I worked on with Dr. Degenhardt in research support. And this was kind of interesting. He brought me 2 bone fragments and then a wedge with a block of wood, and he wanted to make that one piece. And so what I did was scanned the 2 separate pieces of bone and then recreated the base in 3D software. I thought this was pretty interesting of our capabilities of combining scanning and a little bit of modification. This is a partial set of teeth that I had that a faculty member gave me, and I just wanted to test out our Ultra HD scanner, and I thought this would be a good subject matter. And just comparing the size and level of detail to the original, pretty impressive. So I think you can look at this and imagine the possibilities with other types of projects that we can use this technology for. All right, for my final project I wanted to discuss was what started as a Spark Tank project. Definitely a team effort between the Spark Tank students and then Debbie in the library and then myself to make modifications as needed. Basically, we were doing epidural injections, and the goal was to make lumbar and cervical models essentially so that students can practice injections. I was able to take an existing anatomical model of some nerves that we couldn't find a model for, and I basically recreated that in 3D software or we had a vascular piece, and so we didn't have a 3D model of that, so I was able to model that in software. The lumbar discs, we couldn't find an existing 3D model of that, and so we were able to, one of the team members built like a rough mock-up, and so I was able to recreate lumbar discs based on that. This has been a big school-wide team effort, and I just wanted to share this as an example. So if you're interested in something like this, we can talk about it.
All right, some pretty cool applications of that already happening now. And if I was interested in designing or printing these things, how do I go about doing that?
To get things designed, you probably want to get a hold of Jamie Carroll. And the best way to do that is go to service.atsu.edu, which is the website for the ATSU service ticket, or you can contact us directly. It's jcarroll@atsu.edu. That would be for creating things or modifying things. If you have a file that you can download, there's places online like the NIH, National Institutes of Health, has a 3D library.
Oh, cool.
Where you can download objects from that, and those can be printed. And something that the things that is good for would be like an abnormal type thing. You can get any kind of 100 normal hearts on Amazon that are pretty detailed, but the abnormal things where there's something wrong inside the heart, and they can take an MRI and then convert that into an object and be able to print that to show students what an interior view of what an abnormal heart would be.
Cool. And I think we had a few months ago, we had Bruce Young on here that had a bunch of animal models that he had done the same way, I assume.
Yeah, and when we kind of helped him with that, and then I worked with Bruce a little bit to get things kind of figured out and repair some of the models from the scanner. And then Debbie Summers in the library here did the printing on that.
Those were done off of scans of real animals that he had in his lab.
Right, and the hand there you have, like they showed in the video, it was done from a plaster cast of an actual model. And then,
that's cool.
And then shrunk down.
He had tiny hands. I mean, look at that.
That was scaled down for...
this is to scale. Okay, all right. We were learning new things about our university's founder.
If you want to see the real one, it's in the museum here. But the library on both the Missouri and the Arizona campus does a lot of the printing of objects, and then our department would be more of the fabricating and coming up and modifying existing objects.
Cool. All right, so we've got some of the virtual reality stuff covered.
Correct.
Now, and I can see maybe more detail needs to be added, but it seems like as a student that would be a really cool way to get to monkey around with.
And the cost points on those are coming down. They're coming up with more standalone headsets rather than having to be tethered to a computer. So it's getting better, and with the next few years, I think you'll see a lot more of it.
Very good. So what about augmented reality? Because I think as you and I talked yesterday some, and you know way more about this than me, but it seems like there's a lot of applications for augmented reality, maybe that are even more accessible than the full VR.
And the augmented reality, you have a headset, kind of like the VR, but you can see through the front of it. So you're seeing your surroundings, you're seeing the real world. You can, then it overlays 3D objects on the real world where you can walk around them, and it uses cameras to catch where you're at within your location. More and more too, the smartphones are getting in on this. So the object I'll bring up my slide there, Corey. So.
Oh, there's a VR headset.
Yep,
so cool.
That one. So on the screen, that's a Microsoft Hololens, and it's kind of more of the higher end ones. And you can see it's got the clear glass on it where you can see through it. And it's got little camera sensors there, and it projects onto the glass, so you kind of almost like a heads-up display. But as you walk around, it knows where you're at in position in the room, and it maps out the room. And you can put a 3D object in space and manipulate it in space. So that one's kind of cool too. It's kind of the same idea as some of the virtual reality stuff, but you could do some more interesting things. To me, it has more practical application. You can imagine a doctor overlaying an MRI scan on a patient on the table and being able to, for surgeries or something like that, to where you could have, a real view of that particular patient and the anatomy of that patient overlaid on top of the patient.
Oh, very good. Cool.
And I mentioned smartphones too. There are more applications now coming out with smartphones to be able to overlay images on reality. And it's a picture from Microsoft, but some of the anatomy stuff you can do with it. So kind of like you were doing on the other one, but you see your surroundings as well.
Right, which I can see how that would be advantageous.
And it tends to have less motion sickness for people because they have visual cues in their real environment.
Uh-huh.
One of the cool thing about augmented reality is the ability to get information about things in real life. It can recognize things like this is a painting in a museum, and it brings up the information about it when you hold up a tablet to it, to augmented reality. Google Translate was kind of a neat one too, where you can go up to a sign in France and hold your phone or tablet up to it, and it would translate real time what that says.
Well, that's handy. My next trip to France, I'm going to do that for sure.
So that's some of the kind of the cool things, augmented reality. IKEA, some other places are opening up now too, where you can look at virtual models of furniture in your own house.
Oh, yeah.
So you could bring up a couch and say, do I like that couch here?
That's genius.
There's a couple other places now they're doing it. IKEA is kind of the one that started with it. And gaming and stuff like that. Everybody, last summer or last year, we're talking about Pokemon Go and where you're overlaying a virtual 3D object in the real world. And you got kids outside and playing with things, but it's kind of
walking off of bridges.
Right.
Yeah. My son was all over the place with Pokemon Go. There was a number of professors actually you'd see wandering around the parking lot as well. So
yep, and that it kind of it's augmented reality, but people don't think of it that way. They thought it's just a game, but I mean that's what it's doing. It's taking that 3D model and putting it in the real world.
Mm-hmm. Yeah. So I guess we're more familiar with it than we think we are.
Yeah, and some of the other use cases. I mean, past medical and stuff like that. I've heard like Volkswagen factory workers can wear headsets and learn how to fix a machine and do some training stuff like that. So there's a lot of applications and potential for augmented reality.
And you mentioned at the beginning you called it a HUD, and so like the military has used this kind of idea for a long time. With displaying something up onto a lens that you're looking like the windshield.
Yeah.
And even cars use it some now, right?
Some, yeah. It's not 3D.
True.
So it's not a 3D object.
Sure,
It's just a display, but it's kind of that same concept where you're looking at something and you're able to actually see through it as well. And then
you have one.
Brought our HoloLens to do a quick demo on this. Let me minimize that. And
so you're going to play Pokemon Go with the really expensive?
I just might. So this goes over the head. It's got speakers in it. It's actually a little computer in its own. And I can select live stream. I can connect wirelessly to this. So it's its own computer.
There's the production crew again.
And I can give you a quick tour of the studio here. Corey and Barb over there. Corey has a little puppy dog there.
Oh, but he doesn't really. Oh my God, I thought that was really there for a minute.
No, but it's a 3D object that I placed there. And
it's loud.
Yep. But then, I mean, that's kind of, they call them holograms with the HoloLens. So you're putting something in space and able to look at it. And I guess one thing with this, I've got some other menus open here where I can look at it. And I'm controlling it with my hand instead of using a controller you used in the on the virtual reality set. I'm using my hand as a controller for this. So here I've got like a tooth I've placed here in the middle of the room. So you can see all the junk behind it in the studio, but you're also seeing the tooth there. And Jamie Carroll actually created this one. We made it so a dental professor could come around in the classroom, then see, the different structures in the tooth and be able to talk about it and bring it up. And you can, do different things with it as far as, make things bigger or smaller and work with them. Another thing, let me close this. Who's going to cooperate with me? There we go. All right. And so kind of something similar to the one you had there with the virtual reality. I've got an anatomy thing here about the brain for augmented reality. So now it's placing this object here, and I'm able to kind of walk around it and see it. You can see it on the screen, but the people here in the studio can't. They see just air here. And I put my hand through it, and you can kind of see my hand through it. The display is on my glasses.
But it's also able to broadcast it out.
Yes, so I'm going out to a PC, which is broadcasting it out to that. And I'm sorry if I'm moving my head too fast and making people car sick by watching this. My apologies. So I can open this up, and I've got several different things in here I can play with. I can remove different objects.
That took away the skin.
Yeah, it took away the muscles. I can take away the respiratory system. And you can kind of see the circulatory system still there. And some of the vasculature for the head. I can take that away. Now with skeleton, I can pop that open. and
That's ridiculous.
You can explode that. It's got the different things on the face. You can hide that. And then I had just the brain now. And
now you have nothing.
yeah,
Oh, there we go.
I'll explode the brain out a little bit. And there's different programs for this. So you're downloading apps and you're downloading different things. And this one actually has a little feature that lets you click on something and it tells you about it. It gives a little explanation about what it is. So it's kind of a neat way. And then, like Joe was showing on the other thing, you can get up close to it. You can walk around it. It's just kind of hanging there in space.
That's very cool. The fact that you haven't run into anything yet is also
well, and I can see
impressive.
everything around me here.
Yeah.
There we go. And there's like games and things too. There's robo raids, there's little aliens, and you have to shoot them. And so and you can also run a internet browser from here, so you could theoretically do some work and things.
That's what I need to do this afternoon if I can just borrow your
Yep.
headset.
So there's land of dinosaurs, but I mean there's a lot of anatomy. There's one where you can put the stars and the planets in front of you, and for younger kids that'd be great, and for medical application it'd be more for the anatomy type of things.
And I noticed it's got like a visual pointer. You have a little dot in the middle of your screen.
Correct. I got a little cursor.
So it knows what you're looking at.
Right.
Let's start your journey by pinning the Earth in the center of your room. Great. This is our home.
So it's talking to me in
Bigger picture, which is a small
Oh, there it goes.
even bigger picture.
What? Oh, look.
The Milky Way galaxy is made up of hundreds of billions of
That is
stars
too
in the
cool.
solar system.
That's the galaxy, yeah?
Learn and explore by looking around and selecting things that interest you.
so it's just kind of a neat little thing.
This familiar representation of our solar system simplifies sizes and distances so that the sun and all of the planets can be easily seen at once. Click the view button above the sun to talk
Okay.
about this and
It doesn't want to go away.
view.
And see if I can get it to close down now, but not important. All right, we can move on. But they're coming down in price. They're not cheap because it's actually like a laptop or type of computer built inside of this.
How much is that one?
These aren't actually released to the public yet. They're only for, like they call Microsoft developers, about $2,000.
Wow, and the public can't even get one. Because
Right.
I totally want one. For Christmas. For anyone that's making their Christmas list for me right now. That's the coolest. And look, you even look fashionable.
Yeah,
Right.
Don't you agree?
yes.
Of course, yeah.
Highly technical sunglasses.
Very much so.
That's awesome. Hey, I got it to close, by the way.
All right.
Because that's hard. That's the one thing.
That's the hardest part, actually. I
Yeah.
feel like I'm an expert at this point.
And kind of moving on to the next thing I was going to talk about was 360 video, which I threw in here because people kind of put them together because it's a 360 sort of experience, and you can use a headset like a Google Cardboard or like the Oculus here to watch these things and move around as you're moving, and it follows you. But what it is one of these cameras has a lens on the front and a lens on the back, and it captures 360 degrees of video around it.
Oh man, I can't wait to see what happens on the feed when you twist that thing around.
Yeah.
So I think we've all done, even places like Google Earth offer this now, right? You could,
Right.
if you had a little VR headset, you could drop onto a popular landmark and you can look around. It's almost like street views, but it's all attached to your head movement.
Correct.
And so what we got here is a library tour?
That was museum,
Museum.
classrooms, and so this is something I put together for the AOA conference where we kind of went around the campus and we looked at different things. So if you search for the ATSU Campus 360 tour on YouTube, just on the public YouTube search, you can find this. And it tends to work best on PCs, and it tends to work best on the Google Chrome browser.
Oh, very good. Oh, that's cool. So these videos are available to someone, or they can go watch them somewhere?
Right, on YouTube. So, and you don't have to have the, you can watch them on a laptop, kind of like I was doing here, but it's more immersive if you load them onto your YouTube mobile browser, YouTube mobile app, and then you can watch them on your phone if you insert it into one of these devices.
Yeah, very cool. Very cool. Man, don't you guys just want to go play now?
And so, I mean,
We've got all the toys here.
we had all of our toys. We junked up the studio and set all this stuff in here, and just to kind of give people ideas at this point. I mean, Academic Technology is willing to work with people and figure out what we can do to make some of these really innovative things work in a classroom. We're up for experimenting with you. And pretty much, the best way to get a hold of us is through the ITS ticketing system at service.atsu.edu, and just letting us know how we can help you.
Well, that was going to be my next question. So I can't help but watch the stuff and think of, I wonder if I could use that to do this.
Right.
And so you're open to that. If someone who's teaching a class or a student who wants to make a new spark tank proposal, or they can just give you a call and you'll play around or talk it through with them, and maybe
talk it through. And if it's if it's something we can do, we can make it happen.
Very cool.
Yeah, and I mean that kind of goes along with our other services and Academic Technologies. We do all the video work like this. The studio, Corey and Barbara here are doing a great job behind the scenes. If you watch the 360 feed, you can see them over working the switcher. The photography on campus, and then graphics. Jamie Carroll does, besides the 3D graphics, excellent medical and dental illustration. Live event type stuff. We do signage, and we do a lot of different things in Academic Technology.
Right.
So just have to let us know how we can help you out.
Well, Dean, I guess that was a good final word. This has been a fantastic demonstration. I appreciate you dragging all this stuff down here.
And it's really better if you see it in person rather than watching it on a flat screen like that, being immersed in that. So if you want to try this stuff out, let me know too. We can set up a time, an appointment to kind of look at it and check it out.
You better be careful. I'm glad we didn't show them the Star Wars
The Star Wars
game.
thing is really awesome.
You would have a list.
Yeah.
It's like going to Disney World. Just go down to Dean's office. That's cool. Thank you for making the offer. So that's
service.atsu.edu.
.atsu.edu. They use that ticketing system for requests, but it's incredibly responsive. I feel like I use it all the time. So if you have an idea of a way one of the technologies Dean showed us today could maybe work in your classroom or in your department or with a project that you need to tackle, I think they're open to finding as many fruitful and productive applications for this stuff as we can find. And once again, I will add these items to my Christmas list, and we'll put them underneath the produced YouTube video when that package is posted in a couple of days. Thank you for
Sure.
coming and spending time with us. Thanks to all of you who spent your lunch hour joining us for this experimental ride through all of the cool technologies that are making their way onto the scene. Once again, if you watched this broadcast and you'd like to refer someone else to it, first of all, we're still going on Facebook, and I think the way Facebook Live works is it'll post the recording as soon as our live broadcast ends, so you'll be able to go back to it immediately. We're also going to have that up on YouTube, and you got the addresses for both of those there. So definitely check it out again, refer it to a friend. Let us know if there are ways that we could make this production or these presentations better. If you have ideas for topics that you'd like to see us addressed, I'm up for anything. Gene doesn't even write me a script anymore because I make it all up as I go anyway. But we have a good time exploring different things going on in different places within ATSU and all the cool stuff that normally we wouldn't get out and find out about unless it just happened to be right up our alley. So we love doing these Lunch and Learns. Human Resources and ITS and Academic Technologies and all of the departments that come together to put them on. We have a great time doing it, and we're glad that you were able to join us for this episode. Everybody say bye. This is your last chance to wave. All right, they do it now. Hooray. And with that, we're gonna say goodbye for now. We will see you again on the next episode of the Lunch and Learn. Have a good afternoon.